So today in the seminar we are going to discuss the theorem a bounded sequence xn is convergent if and only if limited supreme of xn is equal to limit of infimum xn. So in this proof let us see that the bounded sequence xn be convergent and the limit xn is equal to 1. Since the sequence xn converges to L, every sequence of xn converges to L. So before looking at this, we know that we have to see about theorem 2.8. So here in 2.8.1 we can see that if a sequence xn of real numbers converges to x belongs to R, then any subsequence x dash is equal to xnk of x also converges to x. From this theorem only we come to here the above conclusion, and hence so the set of subsequent limits is the singleton set S is equal to set 1. Hence supreme of x is equal to L, which is equal to the infimum of x. So as we come, we can see that limit supreme of xn is equal to limit supreme of x, which is equal to L, and which is equal to the infimum of x, and which is equal to the limit of infimum of xn. So conversely, we can see that xn be the bounded sequence of real numbers such that limit supreme of xn is equal to limit infimum of xn is equal to 1. Then for any epsilon greater than 0, by theorem 2.9.1 and theorem 2.9.2. From 2.9.1 we are able to understand that xn is a bounded sequence of real numbers, and the following statement is true for the real number L is equivalent, that is L is equal to the limit of supreme of xn if epsilon is greater than 0. There are no most with finite number of n which belongs to n such that L plus epsilon is less than xn, but an infinite number of n belongs to n such that L minus epsilon is less than xn. If is equal to the supreme of xn such that n is greater than or equal to m, then limit L is equal to infimum of that is again the limit of un. And theorem 2.9.2 which says that if x is a bounded sequence of real numbers, the following statements are true, that is L dash is equal to limit of infimum of s, and if epsilon is greater than 0 there is a most finite number. So from these two theorems we are able to conclude that limit supreme of xn is equal to n, that is almost exact a finite number of n belongs to n such that L plus epsilon is less than xn. There exists m1 belongs to n such that xn is less than or equal to L plus epsilon for all n greater than or equal to m1, and limit infimum of xn is equal to L. There are almost a finite number of n belongs to n such that L minus epsilon is greater than or equal to xn, and there exists m2 belongs to n such that xn greater than or equal to 1 minus epsilon for all n greater than or equal to m2. Then we are able to see that m is equal to maximum of m1 and m2. Then from equations 1 and 2 we obtain that L minus epsilon is less than or equal to xn less than or equal to L plus e for all n belongs to greater than or equal to m. So, that is xn minus L. Modulus of xn minus L is less than or equal to epsilon for all n greater than or equal to m. Hence the sequence converges and the limit xn is equal to L.